Welcome to another edition of Lab 207 webcast. My name is Mr. Kite and I'll be hanging out with you today as we continue on in our series about energy resources. Topic for the day is going to be biomass energy. So like I always say, let's get you some objectives and we'll get going for the day. By the end of this video, you want to be able to compare and contrast modern versus fossil carbon and explain the advantages and disadvantages of each type of biomass fuel. So the rest of the videos for this series is going to be all about alternative forms or renewable forms of energy. So today we're going to talk about biomass and then we'll wrap up the series. Before we get into talking about renewable energies, I need to talk about something that I feel like I probably haven't spent enough time talking about yet, so I want to make sure that we hit it right here and we're real clear on it. I want you to understand very clearly that almost every energy source we use, whether it is a renewable energy source or a non-renewable energy source, is somehow derived from the sun. So let me show you a couple things. If we're talking about fossil fuels, this orange column up here, we got the sun. Photosynthesis by ancient plants and algae take the energy from the sun and they store it in sugars. The sugars that are produced from photosynthesis in those ancient plants and algae are stored in petroleum, natural gas, coal, and peat. When we extract these fossil fuels and burn them, we are releasing the energy that was stored by the plant doing photosynthesis millions of years ago. So even though it was so long ago, we are still essentially using energy from the sun in order to power whatever we're trying to do. If we're talking about renewable energy, there are multiple sources. And this up here, you have to burn it in order to get the energy. Talking about renewable energy, there are multiple ways that we use the sun. So you can directly use the sun. That would be using solar panels. No conversion needed, just use a solar panel. There's differential heating of the atmosphere. So this means that the different parts of the atmosphere heat up at different rates, which causes wind. It also runs the water cycle. So in that case, the sun powers wind turbines and wind electricity and hydroelectric power. The sun also heats up the ground, and in the case of heating up the ground, we use ground source heat pumps. We're going to talk about those a little bit later on, but they're used to maintain the temperature and internal atmosphere of a building. And then you've got sun being used for photosynthesis by modern plants and algae. This modern word, this is really important, but you can have it just used for photosynthesis. The energy is stored in wood. You can burn that wood as fuel, or you can take the wood and turn it into charcoal and then burn the charcoal. You can also have other plant parts which could be turned into a biofuel, or those plant parts could be eaten by an animal, producing manure, and then we burn the manure. The only types of energy that we use that are not derived from the sun is nuclear and tidal. So except for these two right here, recognize that somehow, some way, all energy originally comes from the sun. Specific topic for the day is going to be biomass energy. Biomass energy is going to be plant matter that we burn to use for energy, whether it be heating or cooking or as an actual fuel. We're going to talk about the details in a little bit, but know that biomass is some sort of plant matter that we burn. It differs by country. In the developing world, biomass is the primary source of energy. They cut wood from forests, they use that wood for cooking, heating, etc. So if you are in the developing world, it's possible and likely even that biomass is going to be your primary source of energy. In the developed world, it's not nearly as common. It's still used, and it's used in biofuels, which we'll talk about in a second, but just know that developing uses biomass a lot more than developed countries. The examples of biomass that we're going to talk about, so we're going to talk about solid wood, we're going to talk about charcoal. Municipal solid waste isn't one that we're going to spend much time on, so let me mention it here. There are some cities around the world that take the waste that is generated by their city and they burn that waste in order to produce the heat that is needed to run a power plant. So know that that is one option, and biofuels we'll talk about in this little slideshow today. So before we actually get into talking about whether biofuels are better or not, you need to understand this topic of modern versus fossil carbon. Modern carbon, and we're talking about carbon dioxide here, modern carbon is basically the idea that plants that are growing right now are taking carbon dioxide out of the atmosphere and storing that carbon within the body of the plant. When we burn those plants, we release that carbon dioxide back to the atmosphere. So a lot of people look and say, wait a minute, you're still burning something. Anytime you burn something, you're releasing carbon dioxide into the atmosphere. So is that really better than fossil fuels? Because, I mean, the big beef on fossil fuels is that you burn a fossil fuel, you release carbon dioxide to the atmosphere. So is burning plants and releasing carbon dioxide really any different than burning coal and releasing carbon dioxide? That's where this idea of modern versus fossil carbon comes in really handy. So if we are talking about modern carbon, let's say that we have got a tree that is growing right now. Our red tree is taking in carbon dioxide every day. You cut it down, you burn it, you release that carbon dioxide back to the atmosphere. So this right here is kind of like a cycle where our tree takes in the CO2, it stores the CO2, you burn it, it releases the CO2, and it goes back in a circle. This is known as being carbon neutral because you're not increasing the carbon dioxide in the atmosphere, you're just kind of cycling it around. If we talk about a fossil fuel, our dinosaur right here, fossil fuels would have stayed buried beneath the earth. So they were stored in coal or oil or whatever. Those ancient carbons that were taken out of the atmosphere millions of years ago would have stayed stored beneath the surface of the ground and never been released to the atmosphere had humans not found them. However, humans found them, we burn them, so we send them back to the atmosphere. So this is known as being carbon positive because the burning of it adds more carbon to the atmosphere because it would have stayed trapped beneath the ground had we not found it and burnt it and released it into the atmosphere. And doing so, there's also not the trees around to take it back in. So this is fossil carbon right here. This is modern carbon. As we're talking about our biomass fuels, most people will point to this idea to say that biomass fuels are better because they're carbon neutral. They run that carbon in a cycle rather than pulling carbon up out of the ground to burn it. So our solid biomass that you need to be aware of is wood, charcoal, manure. I'm not going to spend much time on this slide because I'm going to go through each one individually, starting with wood. Wood is the most commonly used biofuel. Go around the world, especially in the developing world, it is the biofuel of choice. Now there is the idea of net removal, which is the idea that in most places wood is cut down quicker than it is able to regrow. So this is net removal of the forest. And a lot of people point to wood as a problem for several reasons. First of all is deforestation. Deforestation is kind of a double whammy in that you're cutting trees down, burning them, releasing the carbon dioxide, and then that carbon dioxide would have normally been pulled out of the atmosphere by a tree, but you've just cut down the tree that would have taken the carbon dioxide out of the atmosphere. So you get one whammy in that you burn it and release CO2, and then the second is because the tree is no longer there to pull the carbon dioxide out of the atmosphere. Also, the process of logging obviously causes deforestation that goes along with the erosion and increased water temperatures and all that stuff that we talked about. Also, in the process of deforestation, soil gets disturbed, and when soil is disturbed, it releases carbon dioxide to the atmosphere. So wood is most common, and it can be used sustainably. If you plant a tree for every tree you cut, then you've got wood forever, and we're good to go. So know that wood, while the most common, does have some problems that go along with it. Then we got charcoal. If you take wood, burn it under very specific conditions, it becomes charcoal. Now charcoal is a decent option for biomass fuel because it is lighter than wood, so it's easy to transport. It is twice as energy dense, so you only need half as much charcoal to get the same amount of energy. It burns more cleanly, which means it releases less smoke. Problem with it is it's expensive because it takes a lot of trees to make a little bit of charcoal. And then the last biomass, solid biomass that you need to know about is manure. Yes, that is a pile of cow crap right there, but interesting thing about manure is it's mostly plant mass, so if you let it dry, it burns pretty well. Benefits of using it is if you get rid of that poop, you're removing pathogens from the environment. Great, when no disease is getting into the water. It's also cheap, it's lying around, but when you burn it, it releases a lot of particulate air pollution, and we'll talk about that later on. But know that the burning of manure is responsible for probably 1.5 million deaths worldwide because of the pollution that is caused when it is burned. Now the remainder of this video we're going to talk about biofuels. Biofuels are fuels that are derived from plant crops. They are a liquid fuel. They can be used to replace gasoline or diesel. And the two biofuels that you need to know are ethanol and biodiesel. So let's talk about ethanol first. Here are the major things that you need to know. Ethanol is derived from plant mass. It is an alcohol. If you take plants and ferment them, the sugars in those plants can be broken down, producing ethanol. Ethanol burns very well in an engine. It can be used to replace gasoline in part. In America, we use a fuel called gasohol, which is a mixture of traditional gasoline and ethanol, sometimes 10% ethanol, 90% gasoline, sometimes 15% ethanol, 85% gasoline. Over the last probably 15 years or so, there has been a major policy push in America to move towards ethanol for a couple reasons. One, we grow a lot of corn in the U.S. Most of our ethanol is produced from corn, so it is kind of a logical extension. We got corn, let's make ethanol. Also, there's the idea of getting us to be less dependent on foreign fuels. So if we produce ethanol, we may not have to import as much energy. Around the world, though, Brazil is the world's leader in the production of ethanol. They produce their ethanol with switchgrass and sugarcane rather than the corn like we do. And then I've mentioned gasohol already. So that's kind of the background on ethanol. Now, it is a fairly controversial fuel for a couple reasons. The proponents of it say, great, it is carbon neutral. Those plants, they're using modern carbon. They pull the carbon dioxide out of the air, they store it, we turn it into ethanol, and then we release that carbon dioxide, and it goes in a nice little carbon neutral cycle. Problem is, ethanol is not as energy dense as gasoline, so you can't get as much gas mileage out of it when you burn it, so you need more of it than you would gasoline. Obviously, you have to farm it. Now, farming is a very energy intensive process, uses a lot of cropland, disturbs soil, which uses carbon dioxide. You use regular fossil fuels in order to conduct the farming process. Some people will actually argue that the production of ethanol releases more carbon dioxide than you actually save by using fossil fuels, because you're not just digging it up and burning it directly. You got to farm all that corn, process the corn, turn it into ethanol, and then you can use it in the car. So people argue both ways: good because it's modern carbon, bad because you might actually end up using fossil fuels and producing more carbon dioxide just to make that ethanol. And we'll wrap up with biodiesel. Biodiesel is derived from the oil that can be taken from algae or plants. It's manufactured into a fuel called B20, which is a mixture of 20% biodiesel and then traditional diesel fuel. A couple things on it. It requires a higher temperature for combustion, so engines must be modified before they can burn biodiesel. It usually takes a special engine to burn biodiesel, but it's kind of an interesting idea because like acre for acre, growing algae in order to get the oils for biodiesel produces a lot more fuel per acre than ethanol or other fuel alternatives. So a lot of people look at biodiesel and say, hey, that's possibly a really good idea. There's also the idea of straight vegetable oil. That's the SVO conversion. You can get cheap kits where you can turn a regular diesel engine into an engine that can burn vegetable oil. So you go to a restaurant, you get their used cooking oil, you filter it, you throw it in your engine. Your car smells like a French fryer while you're driving, but you can run off of it. And a lot of people say this is the best idea ever because it's like minimal processing. You get like dual use, cook with the oil, then burn it in your car. It is carbon neutral because it is an oil that was made from corn, so it's modern carbon. So that would be biodiesel. Those are your biomass fuels. Hope you found this little tutorial helpful. Thanks for joining us on the Lab 207 webcast. My name is Mr. Kite. We'll see you again.